Let us do synthetic division. Synthetic division is a method of factorizing cubic functions. I have 3 questions here that I've put up together to explain the method. Now let's begin. If f, we have got a cubic function given, then the information says if f of 2 is equal to 0, we need to understand what that means. Now, if f of 2 is equal to 0, then it means, so here we have got f of 2. If f of 2 is equal to 0, what does it mean? What it means here is that x is equal to 2. And if x is equal to 2, then it follows that x minus 2 is one of the factors of the given expression. I'll say it again. If f of 2 is equal to 0, it means x is equal to 2, and therefore x minus 2 is one of the factors of the given expression. So if we factorize this given expression, one of the brackets there must be x minus 2. Now, how do we find the brackets using the synthetic division? The value of x that we are given here, x is equal to 2. We write the 2 first. Then the coefficients of this expression, the coefficient of x cubed is 1. The coefficient of x squared is negative 1. The coefficient of x is negative 8. And the last value is 12. These 4 numbers, the coefficient of x cubed, the coefficient of x squared, the coefficient of x, and the constant, we write them next. 1 minus 1 minus 8 and 12. Now I have got 5 numbers. Let's be clear about where these numbers are coming from. The first one is the value of x. So this is coming from f of 2 is equal to 0. That 2 there is the one that we are using. Then these 1, 2, 3, 4 numbers, they are coming from the coefficients of the expression that we are factorizing. Then we begin our calculation in the following way. The first value that I have, this one here, you bring this number down at the bottom here and write it down 1. Then the value of x that we have and this one, they multiply each other. The answer that you get, you write it in the next column. 2 times 1 is 2. The answer, we write it here, 2. Then after that, you add these 2 numbers and write the answer at the bottom. Minus 1 plus 2 equals to 1. Then you multiply again the value of x multiplied by this one and get an answer. The answer that you get, you write it under the next column. 2 times 1 is equal to 2. Then you add these 2 numbers. Minus 8 plus 2 gives me minus 6. Then you multiply again. 2 multiplied by negative 6. Write the answer in the next column. It will give us negative 12. Then add these 2 numbers to get 0. This is how synthetic division is done. So quickly, to emphasize where our numbers are coming from, it's important that we know. The first one, this 2 here, is coming from f of 2 is equal to 0. This is given in the question, f of 2 is equal to 0. Then this one, that one, that one, and that one, they are coming from the coefficients of the expression that you are factorizing. Your synthetic division starts by writing this number down here. You take that number down then you multiply. It's kind of a cycle. Multiply, write the answer in the next column, add. Multiply, write the answer in the next column, add. Multiply, write the answer in the next column, add, until you get to the last one. If the number that has been used here, if f of 2 is equal to 0, like what is stated here, when you are done with your division, at the bottom here, you must get 0. This 0 must appear at the end. That is synthetic division. When done up to this level, the first value that we get is the value of a in ax squared. The second value is the value of b in bx, and the next one is the value of c. So these 1, 2, 3 numbers are values of ax squared plus bx plus c. Now to proceed with our factorization, f of x, which is the expression that we are factorizing, is equal to the first factor is x minus 2, like we discussed before. So you write x minus 2. The second factor is ax squared plus bx plus c. The values of a, b, and c are these three numbers that we got at the bottom. So if you put 1, the first one is going to be 1x squared. The second one is going to be 1x. And the last one is negative 6. Then to complete your factorization, you go ahead and factorize the quadratic part to produce 2 more brackets. So this will give us x plus 3 factor of x minus 2. Then we have fully factorized the quadratic function. Should we be required to solve this and find the values of x, then we equate f of x to 0, which means all these 3 brackets are going to equal 0. The first bracket will give us x is equal to 2, and the next one will give us x is equal to negative 3. The next one will also give us x is equal to 2. It is the same value. That is our expression factorized. So we are going to be drawing graphs of cubic functions. This is necessary in determining the x-intercepts of the function. Just to emphasize, let's have one more problem solved. Now I have an expression given. This one says prove that x plus 3 is a factor of f of x. Now, it is exactly the same expression as the one on the left here, but it is expressed differently. So we can say that if x plus 3 is a factor, if x plus 3 is a factor, if x plus 3 is a factor of f, what exactly does it mean? It means x is equal to negative of 3. It means f of negative 3 must equal to 0 all the time. So to prove what is required here, you substitute x with negative 3, and the answer that you get must equal to 0. So in this case, I want to do synthetic division, so I'm going to set it out in the following way. The value of x from the given factor is negative 3. So I write down negative 3. Then you write the coefficients of this given expression. The coefficient of x cubed is 1. The coefficient of x squared is negative 4. The coefficient of x is negative 11. The last term is 30. Those 4 numbers are the ones that follow this expression. 1, negative 4, negative 11, and 30. Please remember, these numbers are coming from the coefficients of the given expression. The first value, you bring it down here. Then you begin the cycle of multiply, add the answer in the next column, and write it down. Multiply. So we start here. Multiply, add the answer in the next column, and add the numbers. Multiply, add the answer in the put the number in the next column, add. Multiply, write the answer, add. Multiply, write the answer, add. So if we add these two numbers here, they are going to give us -7. Then multiply, write the answer in the next column, and add the numbers. Repeat the process. Multiply, add the answer in the next column, and add the numbers. Now, if x plus 3 is a factor like as is stated, then you must get 0 at the end here. Now remember the numbers that we have from our expression. What are they representing? Now these numbers, the first one that I have is this is x squared, then plus bx plus c. That is what those numbers represent. My expression after writing down one factor becomes, it has a one bracket which is a quadratic one. So we can say f of x is equal to, in factorized form, the first factor is the given one, which is x plus 3. The second factor is going to be ax squared plus bx plus c. In place of a, b, c, we put the three values that we got. So it's going to be x squared minus 7x plus 10. To complete your factorization, you factorize the quadratic part. So this is x plus 3, factor of x squared minus, and in factorized form, this will be x minus 5, factor of x minus 2. Then your expression is factorized fully as is required by the question. That's synthetic division. Just to emphasize again, number 3, I have this expression here. Now, for me to begin my factorization, I need one value, one number that can give me 0 if I substitute into x. In my case, the number is -1. So -1 cubed plus 1, the answer is equal to 0. This means x is equal to -1, and therefore x plus 1 in brackets is a factor. Now, how do we find the other remaining factors using synthetic division? The value of x is a -1. So we're going to have 1. The value of x is a -1. Therefore, the factor is x plus 1. That is what we need. So if you do synthetic division, now we need to notice something very interesting here. This expression here has got two terms. Our synthetic division must follow standard form. We have ax cubed plus bx squared plus cx and then plus d. Now, where we have got x cubed plus 1, and I want to put this in synthetic division, you will see that what happens now is that in place of b and c, you put 0. So the coefficients are going to be 1, 0, 0, and then 1. And then this side, you need one value of x that you can put in x in this expression to get 0. Once you do that, Then you can set out your division and continue with the synthetic division until you get your answer. That is synthetic division. I'll leave this for you to do and see if you can get it right. Synthetic division, grade 12 cubic function. We have done synthetic division as a method of factorizing cubic functions. Just to summarize quickly, we need to understand where these numbers are coming from. The first value is this 2 here. It's coming from f of 2 is equal to 0. So this must be the value for x. X is equal to 2. And keep in mind that sometimes it can be given to you as a bracket. So if it's given in bracket form, it will be x minus 2. Then we can get x is equal to 2. The next value, the coefficient of x cubed is 1. That is the one I have here. The coefficient of x squared is negative 1. That's the negative 1. The coefficient of x is negative 8. That's the one I have here. Then the constant term is 12. That's the 12 I have there. Then to do the division, this one, you bring it down here as it is. Then you start the cycle of multiply, write the answer in the next column, and add the 2. 2 times 1 is 2. Add these numbers and write the answer at the bottom. Multiply again, write the answer in the next column, add the 2 numbers, write the answer at the bottom. Multiply again, write the answer in the next column, add the 2 numbers, and write the answer at the bottom. Then the 3 values that you get at the bottom here are going to be the values of a, b, c in the expression ax squared plus bx plus c. Then a is 1, b is 1, and c is negative 6. Then this quadratic expression that comes up, we have to factorize it into 2 more brackets, combine it with the first factor that we have, and that will complete our synthetic division. Thank you very much for watching. I hope it helps you understand this section of factorizing cubic functions. Till we meet again.